The next lesson that we're going to discuss is Chapter 0, Section 2, Real Numbers. Real numbers are made up of many different types of numbers. The first number we have is the natural numbers. Natural numbers, or N, are the set of numbers that start with 1 and go up without decimals. So how do we represent that? Again, natural numbers start 1, and then they go up to 2, and then they go up 3, etc., etc. And if I fill this in on the number line, I can see that my natural numbers progress up towards infinity, but there are no decimals with natural numbers. Natural numbers are referred to as natural numbers because they are the numbers that babies learn. After natural numbers, we get into whole numbers. Whole numbers include all of the natural numbers. So the 1, 2, 3, 4, and 5 will continue. What makes whole numbers is that we add 0. We go from natural numbers that we learn on our own to whole numbers, and whole numbers include all of the numbers starting at 0 up towards infinity without decimals. Natural numbers are the way that we speak naturally. Whole numbers introduce the concept of 0. Whole numbers are also represented by the letter W. Next, we have integers. Integers include all of the whole numbers. However, integers are the whole numbers and their opposites. So 0 has no opposite, but 1, the opposite of positive 1, is negative 1. And the opposite of 2 is negative 2. The opposite of 3 is negative 3. The opposite of 4 is negative 4. The opposite of 5 is negative 5. And because these lines have arrows, that means that this will continue towards infinity. After integers, we have what is called rational numbers. Rational numbers, sometimes known as the letter Q, as quotients. The rational numbers are numbers that can be expressed as the ratio of A over B, where A and B are integers and B is not 0. So that means that there can be no decimals because they are integers, and the denominator cannot be 0. So here we have negative 4, negative 2, 0, 1, 3, and 5, which are integers, whole numbers, and natural numbers, but they are also rational numbers because I can write them as fractions. Negative 4 over 1, negative 2 over 1, 0 over 1, 1 over 1, 3 over 1, and 5 over 1. I can make any whole number or any integer or any natural number a fraction just by adding a 1 underneath it. I also have decimals, and rational numbers are when we start seeing decimals. Negative 4.3 is between negative 4 and negative 5. Negative 0.7 is between negative 1 and 0, and onward. Even though these have decimals, I can rewrite them as fractions. If I take negative 13 and divide it by 3, I will get this repeating decimal. If I take negative 7 and divide it by 10, that gives me negative 7/10. This decimal is terminating. If I take 13 and divide it by 9, an integer divided by an integer, I get 1.4 repeating. An integer divided by an integer gives me 2.5, a terminating decimal. 73 divided by 20 gives me 3.65, another terminating decimal. As long as the decimal repeats or terminates, it is considered a rational number. Here are examples of irrational numbers. Irrational numbers are decimals that cannot be written as a quotient of two integers. So these are the numbers that do not terminate and do not repeat. So for example, if I have the square root of 3, if I use my calculator, I get a decimal that does not repeat and has no discernible pattern. It will continue to go on forever. This is considered irrational. So any number under a radical that does not simplify to a perfect square is considered irrational. Another example is this symbol, which is the word pi, pi, which can become 3.14159, etc., 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 etc. It never ends, it doesn't round. Pi is an example of an irrational number. This is the value of e that we use with logarithms. E is also a standard decimal value that repeats without end and does not terminate. Therefore, it is considered an irrational number. So here are some examples, and we're going to sort them. So drag each number into the correct bin. The square root of 27 cannot be simplified, so therefore it will become irrational. If I type the square root of 27 into my calculator, it does not give me anything but a decimal. The square root of 18 is not a perfect square, so therefore it will be considered irrational. The square root of 144, however, is considered rational because the square root of 144 becomes 12. The square root of 1 simplifies to 1, therefore it is rational. The square root of negative 36, well, that becomes rational even though it has a negative, because the square root of 36 is 6, and because there's a negative on the outside, it becomes negative 6. The final example that we have is negative 50. The square root of 50, if you type it into your calculator, gives you a decimal that does not terminate and it does not repeat. Therefore, it is considered irrational. Here's an example of a chart that we are going to be entering into our interactive notebook. Rational and irrational numbers form the set of real numbers R. So we're going to drag the labels in here to see. We are going to be putting a copy of this into our interactive notebook. So the first numbers that we start with, which are the smallest numbers, are the natural numbers. Natural numbers are all the numbers that increase from 1 up towards infinity. So we have 3 and we have 200. The next set of numbers are the whole numbers, and whole numbers include all of the natural numbers, and we add 0. After that, we introduce negative numbers. Well, negative numbers without decimals give us integers. And finally, we introduce our decimals and our fractions and our repeating decimals and everything that is also included in all the circles below, and that gives us our rationals. So this helps us remember that natural numbers, whole numbers include the natural numbers plus 0. Integers include the whole numbers, the natural numbers, and the negatives. And rational numbers include all the integers, all the whole numbers, all the natural numbers, and all of the fractions and decimals that terminate or repeat. Everything else becomes an irrational number, but remember that every number that we are going to be studying are real numbers. Here are some examples. Negative 7 would be considered a real number. Negative 7 would be considered an integer, which is represented by the letter Z. And negative 7 will also be rational, which is represented by the letter Q. And then I can check. So again, it is real, it is an integer, and it is rational. 6.5, it's first going to be real, because all of the numbers that we discuss are going to be real. After we have real, we notice it has a decimal. So it cannot be a whole number, it cannot be a natural number, it cannot be an integer, which leaves us rational. So it's R and Q. Our next example is the square root of 2. The square root of 2 is going to be a real number because every number that we are dealing with is real. But because it is under a square root sign and it does not simplify out to a perfect square, it is going to be irrational, which is I. 0 is going to be real. It's not a natural number, but it is a whole number. It is also going to be an integer, which is the letter Z, and it will also be a rational number, which is Q. The only one that 0 does not belong to are the natural numbers. Please make sure to bring any questions you have to class, and note that we are going to be completing a section in our interactive notebook on this topic.